Thank you so much. So I'm going to be talking about new weed management technologies for orchards and vineyards. This is an area that I'm going, whether it's with the processing vegetable industry that I work with, or whether it's our grape industry or our apple industry, mostly because I don't think we can keep doing business with respect to weed management as we have in the past. And I just happen to be really interested in equipment and robots. So that's where I'm thinking. So starting with weeds in perennial crops, this is kind of my obligatory slide of why weeds are bad. You know, competition, particularly during the establishment phase, large vegetation impacting the deposition of other crop protection chemicals, the habitat for vertebrate or invertebrate pests, interfering with crop production or harvest operations, and then hazards for human laborers. One of the big questions I get in New York State is, I have poison ivy in my apple orchard, and how do I manage it? So with respect to habitat for vertebrate and invertebrate pests, I think certainly on the East Coast, this is our biggest threat with our wine industry, our grape industry. Tree of heaven. Tree of heaven is an invasive tree species and a preferred host for spotted lanternfly. One thing to note, this picture of tree of heaven, I actually took here in Washington State, up near Wenatchee. This is actually tree of heaven creeping into a cherry orchard. So we're using herbicides frequently for weed management. This is across all crops within the United States. And this is just some data from the 2022 Census of Ag. Now, this is across all crops, all commodities. But basically, what it is saying is that we are putting out more herbicides across more acres, across more farms, and we are putting out insecticides and fungicides combined. We use a lot of herbicides for weed management. And that's also in the grape industry. So I don't know if this data still represents the Washington grape industry, but this is the survey that I did, or a portion of the survey, looking at what weed management strategies were employed in Washington vineyards under the trellis and between the rows. And you can see those first two bars on the left. That's pre-emergence soil applied residual herbicides and the post-emergence foliar applied herbicides. They were being used by 60 to 80% of growers for managing weeds underneath the trellis. Now, we're heavily reliant on herbicides, but I think we need to adapt. We need to change. And the reason is that herbicides can limit our access to export markets. There's a lot of consumer perceptions that are changing about pesticide use. We need to be thinking about worker protection and crop injury concerns. That crop injury concern, that lower, that's actually allion injury in a young vineyard. That was actually in California. And actually that was the University of California. They called me and they said, oh, we did something wrong. And that went away, that block went away real fast. But also people ask me, like, well, when is the next chemical coming? When is the next herbicide coming? And then this is my thing, is like, don't count on it. If it's not that the companies aren't involved in discovery and commercialization, they clearly are. But let's face it, they're looking at agronomic crops first. And then those chemical technologies trickle into the lower acreage, much higher value specialty crops. But you need to understand, pesticide development is costly. It can take hundreds of millions of dollars to bring a new pesticide from discovery to commercialization, and it can take decades for this process. I was talking to a Syngenta colleague. She said, I will have a new molecule for you to test maybe this year or next. We have an anticipated commercialization date of 2035. Okay, so it's not to say that there aren't molecules out there. It's not to say that the IR4 project isn't working at bringing chemistries from other crop systems into specialty crops. I've looked at several in grapes myself. It's just, I think that day and age of where there was a new chemistry coming out, like every year, we've hit a plateau. And so I don't think that we can necessarily rely on this anymore. The other problem is that we have a growing herbicide resistance problem. Right now, there's 534 unique cases around the world to 168 different herbicides. 131 of those cases are in the United States. We look at the region here. There's 51 reports of herbicide resistance. Now, yes, the majority of these come from wheat and cereals and grass seed, but there's certainly 2 from orchard systems, and I'm going to bet that number is a lot higher than just 2. If we're looking at orchards and vineyards, there's 111 reports of herbicide resistance globally, 12 reports within the United States, and that includes my own recent report in New York State of glyphosate and paraquat resistance in our horseweed populations that come from our tree and vine systems. There's also the Endangered Species Act we have to think about, which is going to change the way we use pesticides. It has the potential to change the way we use pesticides. So to meet our statutory obligations under the Endangered Species Act, we're going to see changes to herbicide, insecticide, and fungicide labels. The first herbicide label that's gone through this ESA work plan herbicide strategy is already out on the market. Now, things can change. I just saw this in the Federal Register that they're rescinding the definition of harm under the Endangered Species Act. So we're still waiting to see what that means. But my suggestion is I still don't think we can continue to go on the same way. So what does sustainable weed management look like? You know, there's a lot of things to think about if we're not using herbicides, and if we are reliant on labor, and labor is going to be difficult to source and it's going to be costly to source, you know, what should we be thinking? Now, there are people looking at expanding cover cropping, you know, into vineyards, not just in the inter-row area. There's people looking at grazing. That is not me. I can't do everything. And also I did one grazing trial in walnuts in California. The sheep got out. I am not going there ever again, because when I'm no cell service trying to text like crap, the sheep are out, you know, like what am I? Yeah, that's somebody else's plan, and you can invite them next year to do that. But I want to talk about technology for weed control and some of the work that I have done. So the reason I'm focused on technology is there's been a lot of discussion within my society, the Weed Science Society of America, about what weed control is going to look like in the future. And there is a lot of discussion about what robotic weeders, what vision sprayers, what electric weeders, thermal weeders, laser weeders can do, and how they can be integrated into our crop production systems. So I want to talk about targeted, you know, spraying, vision guided spraying, some of the work we've done with the weeded system, and then electrical weeding. So what is targeted spraying? Basically, this is technology that's going to allow us to be much more precise with the application of our herbicides. We're going to put them down to individual plants instead of, and think foliar herbicides, like contact herbicides. We're going to put them down on individual plants, and we're either going to use GPS mapping, where we know we have populations that we need to treat, or we're going to use sensors that are going to identify and target the weed species to make this very precise application. And this is a shift away from how we've done things, moving from this kind of broad field approach to just focusing on individual weeds that need to be treated. And I'm very interested, can we leverage the technology we have for our large acre commodities for use in specialty crops? And what I've been working with, I don't have the capacity to build my own see and spray system, so I'm going to go out there and get what's out there. And the one I've looked at and I've been focusing on is Agritech America's weeded system, where they're really looking for fallow weed control instead of going out and just, you know, putting, again, broadcast applications where we don't have any weeds. Can we just target the weeds? And they use a unique see and spray system where it's chlorophyll based. So you have a sensor that emits blue light. My system has blue light. The newer systems have a red light wavelength. And basically the plants absorb, the chlorophyll absorbs that light and then it emits a signal in return to that light source. And then the sensors pick up that signal. And if there is a weed there and the sensor picks it up, what it does, it just triggers a nozzle to turn on and just spray the weeds there. There is no crop weed discrimination. So it's not going to be like the carbon robotics laser weeder. It's not going to be like the verdant robotic sharpshooter, the eco robotics that's making crop weed discrimination. So it's a faster system. We can move a lot faster because we're just looking at the chlorophyll. We don't have to do as much processing. But you need to have your sensitive commodity separated either in time or space. So either, again, fallow system where you don't have a crop up and you can spray, or space. And this is where grapes come in because the canopy is up here, the weeds are down here. So can we have that physical separation between desirable tissue and undesirable tissue and use this for weed control? This is just our system. We just put it onto an ATV. Which is housing the carrying the weeded system. That green box, that is the light source and the sensors. You can see the light, the blue light shining on the ground, and then you can see we have it divided up into little quadrats there. And there's 4 sensors and there's 4 sections. So if there's a weed in section 1, it turns on the nozzle for, section 1. If there's a weed in section 3, it turns on the nozzle for section 3. So we don't have this continuous application. And we're really interested in this for specialty crops. So can we reduce the amount of herbicide that we're applying? Can we reduce potential crop injury associated with post-emergence applications? Can we possibly bring new herbicides online? Because that could control either herbicide-resistant weeds or perennial weeds, because we can improve the crop safety potential. And does this, can we also, is this be a mitigation strategy for meeting Endangered Species Act requirements? Because we're not putting out as much herbicide on a per acre basis. And again, I see a value for this in our perennial cropping systems because we have this separation of tissue between the crop and the weeds. So this is just a study that I did. This was funded by the IR4 program through their Integrated Solutions program to use a weed it to evaluate different herbicides in Seyval Blanc grapes. This was at our Clairol station. So we had Rely, Reglone, which are contact herbicides. We had 2 organic herbicides. Maybe if we were with our precision applications, we put them out at a slightly higher rate and, maybe make the use of organic herbicides more cost effective. And you'll notice I have 2 in there, Embed Extra, which is 2,4-D, and Tenacity, which is mesotrione. These herbicides do not mix with grapes. But this was our 2 products that were in there to see if we could, these would be our tools for, can we improve crop safety using the technology. So where we just did our continuous directed applications under the vine, we just used our backpack sprayer, and then we used our weeded system for our vision guided spray. And I'm just gonna go over the data really quickly, is that if we're looking at weed control, the starting weed cover makes or breaks the system. When we had very high cover, so year 1, we didn't get the weeded system in time. It arrived a little bit late. The weeds were growing. We had 50% cover when we started spraying. And it was the targeted sprayer. It reduced the number of weeds, but it didn't match, our conventional application. However, in 2021, we got in a lot earlier. Our weed cover was a lot lower when we started applying. Less than 20%, and both systems were equally effective, and we use less herbicide with the weeded system. So this is really mostly going to work with our post-emergence, contact herbicide, contact or systemic herbicides. Products with residual activity, I don't think are a good fit for the system, especially if you want the residual activity to be a part of your weed management program, because you want the even distribution to the soil. If you're going to be spot spraying, then you're going to lose the value of having that even application and that residual control. But this is just some of the data. So this is just showing Rely 280, some of our results. There, the red line, that is where our conventional application. The gray line, just right above it was our vision sprayer. This was again in 2020. We started off with 50% weed cover. Both were better than our untreated check, but we didn't quite match what our conventional strategy did. Now, I wanted to bring this up. This is the same in 2020. This is tenacity. This is mesotrione. Mesotrione has residual activity. We had a lot of pigweed in the site. And what happened is you'll notice that the mesotrione, where we put it out in our conventional, that red application, we barely had any weeds in that plot. That's because we had a lot of rain. We got the tenacity incorporated. So we weren't just looking apples to apples. We were looking apples to oranges, because with our banded sprayer, we were just doing weed control with just kind of the spot spray. Whereas with our conventional banded application, we got the residual weed control. And so it persisted. So that's why I'm saying, and this technology, if what you want is residual weed control, this isn't going to be the product. Now, if we're looking at grape injury, crop safety, there was definitely a herbicide by application system interaction. I want to make a point is that we applied these directly to the base of the vines. There was no contact with suckers or vines. We didn't see any injury, regardless of how we applied the herbicides for the Rely, the Reglone, the Axe, or the Home Plate. However, where we had tenacity and 2,4-D, again, two herbicides that can be very injurious to grapes, we didn't see the same amount of injury where we used the Weed It. And I'm going to bring up the 2,4-D. This is the injury that from my regular application in the grapes. Terry Bates is probably not thrilled with me, because I was like, gonna hurt, Terry. But just to show you the difference in injury between the Weed It system and this conventional application. Where we had the conventional application, those are the gray bars. You can see the injury in the canopy is much higher, up to that, 20+%, whereas the red bars are where the Weed It, and we saw maybe 1, 2, 3% injury. So substantially reduced the injury potential. So my next question is, okay, so we can see the weeds, we can spray the weeds. Could we use this for crop management? Could we spray the suckers? Could we use the Weed It system to see and spray suckers? Because a lot of times in a lot of our vineyards in New York, we've got a guy growing around, sitting on a tractor with a wand, stopping and spraying, stopping and spraying, stopping and spraying. So could we do this a lot faster? Or we're using hand labor to do it. So if we can see and spray weeds, can we see and spray suckers? So reduce the need for hand labor. Prevent physical damage to the vines from mechanical practices, and reduce herbicide inputs, and reduce the potential for off-target movement. And this was my colleague down in New Jersey. We duplicated this trial both in New York and in New Jersey. And just him driving along, letting the Weed It spray. So basically, we had. This was last year. We basically had a manual removal process. We had a spray wand application. We used AIM at 2 ounces per acre, and then we used our Weed It system. We also looked at a couple other herbicides that aren't necessarily registered. We're just evaluating them for sucker control. But I'm gonna stick to the AIM, and these are just show you visually what the results look like, where we didn't do any sucker control versus the hand removal. You can start to see some of the regrowth from the hand removal, but where we did the spray wand or the Weed It with the AIM, equally effective at removing those suckers. So this is again just showing the data, looking at the biomass, what the biomass looked like if we didn't remove the suckers at all. This was taken throughout 30 days after we made our treatments, but basically the Weed It is looking as good as the spray wand, is looking as good as the hand weeding crew that went through. So the Weed It was as good. It was as fast, or it was faster, obviously, than a hand weeding crew. We were faster than we were with the spray wand, and we used less herbicide, significantly less herbicide making these applications. And we're working on writing this up for Hort technology right now. So just across all our trials, we did see less herbicide use with the weed it system. How much really depends on the amount of tissue to be treated, whether it's the weeds or the sucker. So I really think the benefits of this technology are going to decrease with increasing weed cover. The more you have to see and spray, the less different this is going to look from a conventional application. And we're still trying to understand if some herbicides are better for see and spray systems than other herbicides when we're looking at our foliar post-applied products. But the next step, what we're doing is more automation because the robotics, my robotics colleague and I they just more robotics at it. So if the weed is autonomously seeing and spraying the weeds, can we actually put our system on this autonomous Amiga robot? Can we program our vineyard blocks in and then basically just set this off and have it go spray our vineyard itself? So this is what the New York Wine and Grape Foundation, they've indulged me in my fancies here, and they're very interested in the automation process. And so they're funding this research trial to see if we can't fully automate our weed and sucker control operations in the vineyard. The other thing with the Amiga, my colleague Young is really interested in, can we get these Amigas to talk to each other? So can we basically have them as a swarm? And so that all the Amigas know where they are and they can all go out and work independently, but not overlap with each other. Again, I brought up the see and spray system because right now, precision spraying equipment that you can allow for the use of less pesticide is a tool that is going to be valuable with Endangered Species Act compliance as mitigation strategies. Right now, with our herbicides, we're going to be on a 9-point system. You need to get so many points to use herbicides, and based on the mitigation practices in place. And this is going to be one of those tools to reduce the amount of herbicides applied. So the next thing I'm going to talk about is electrical weeding, which is just that. It is basically electrocuting the weeds. And it's not new technology. It's very old. It was issued the first patents were issued in the 1890s. We explored it in sugar beets in the 1970s and 80s. Basically, the physical contact of your unwanted plant with a high voltage electrode, you get a current flow through the plant. That heat disrupts the cells. That leads to the tissues wilting and dying. It even passes into the roots a little bit, so it's a little systemic. And it's being touted because it's herbicide free and no soil disturbance. So the company we're working with is Zaso. They're originally out of Brazil. They've been bought by a German company. And this is my unit. This was designed for coffee plantations. I got it during the pandemic. You have to take what you can get. It's a little bit bigger than I want. But again, you take what this is what you got. What it is, though, is that we have a generator and transformer. It's powered by the power takeoff unit of our tractor. We have the front mounted applicators that go, underneath the canopy. And then we have those metal flexible electrodes that where the current is passed to the weeds. And this is my unit. This is in New York when we first got it. And everyone says, well, where's the arcing and sparking? I'm going to say it might be a little different for y'all out here. But Marcelo Moretti at Oregon State and Brad Hansen at UC Davis are doing all the trials out here under Western conditions, looking at winter weed management primarily. So that's my system. Like, well, that's anticlimactic, but this is what we saw. This is 24 hours after treatment. You can start to see the wilting and the tissue, and then 1 week after treatment. Also, that first where we actually had nut sedge, and this is our untreated check, and some of what we saw with our nut sedge control. We do think there's a timing issue, but we're very interested in what we can do with perennial weeds and how much control we can achieve. So my graduate student, Aaliyah Butler-Jones, is looking at how well we can use electrical weeding in an organic apple production system, because this is sponsored by the OREI. She's looking, comparing it to cultivation, which is our standard that we're pretty much using in New York, and organic herbicides for organic apple control. And that's our unit in one of our organic apple blocks. And I'm going to tell you that block is all perennial weeds. These are just some example of the perennial weeds we have out there, but we counted about 20 different perennial weed species because it's been organic for quite some time. So we wanted to look at how well does the electrical weeding compare to the Wonder Weeder cultivation and the organic herbicide. And we made a single monthly application, like the 15th of each month in like May, June, July, August, September. And then this is my unit. Oh, that's loud, sorry. That's my unit running in our organic apple orchard. By the way, the one flaw you'll see is we don't get between the trees. I do have a unit that has a spring arm, applicator has a spring arm on it that can bounce back and forth. We're still working on getting that one operational. But this is just showing a weed cover. Aaliyah has tons and tons and tons of data, but just showing the weed cover over time. We started in May. You can see we're up around about 50% covered. That black line is the organic herbicide. The gray line is cultivation. The red line is Zaso. And you can see we're doing better with suppressing those weeds with the electrical weeding. If you're wondering why there was a giant spike there in July, that's when we had 8 inches of rain. And so we had 8 inches of rain that year, and we're not running an electrical weeder when we have 8 inches of rain. So the weeds regrew, really, yeah. And then we finally got back in again in August. But I want you to see is that the Zaso was always better than our cultivation. And by the end of the season, we're looking at very low weed cover in those plots. This is the end of season dry biomass. Really significant differences. Aaliyah has also done a study where we've actually gone in with the electrical weeder first, and then a week later we come back with the cultivation and found that it provides even better and more long-lasting weed control, where we stack those two technologies on top of each other. Because the plants start to, they're already injured by the electrical weeding, and then it makes the cultivation go faster and easier. And it does more damage to those perennial plants. So we're revamping the trials this year to look at these stacked traits. So everyone asks about crop health. There is no damage to the trunks. We didn't damage the tree. We hit one because we turned a little too close. And so we don't count that one. But the electricity has not damaged the trees themselves. We've had no impacts on our canopy size. We've had no impacts on leafing out. We've had no impacts on bloom phenology in our trials. Like I said, my student Aaliyah has tons and tons and tons of data. And what about soil health? What about the electrical current moving through the soil? She is still counting so many soil microarthropods, but right now we are not seeing dramatic changes or shifts in response to the electrical weeding. So we haven't seen any microbial changes. We haven't seen any microarthropod changes. The downside is it did absolutely nothing to the soil seed bank. Those weed seeds germinated just fine because soil is a good insulator. Now, it took a lot more fuel and it took more time compared to the cultivation. It is significantly more, but we're also saying if you can get better weed control over time, do these bars start to even out, and do you gain more? So we're still working on the economics of this. We're repeating these trials. We've got 2 apple blocks this year. We're doing it in blueberries, 2 blueberry blocks this year. We are integrating our practices, electrical weeding and cultivation. We're looking at compared to mulches, herbicides, both conventional and organic. I'm trying to get an autonomous mower because my grape growers have said, well, what if we could just have an autonomous mower running through, and could it act as a bird deterrent for us? We're really not interested in eliminating all the weeds. Could we just keep them down? So I'm looking at an autonomous mower. We're looking at it for bindweed control in grapes. Bindweed is a huge problem for us. We are doing that economic analysis. And like I said, it looks like it's costly and slower in the short term, but can performance over time reduce the frequency of use? So, technology for weed control, is it sustainable? This is really focused on sustainability. And I'm gonna say, how do you measure sustainability, right? If sustainability is, I want to put out less herbicides, and yeah, maybe it is. I had another grower say, yeah, but you know what? I don't want to use more diesel. So then maybe not. Another grower is like, I like it because I don't have soil disturbance. So I think there's a lot of thoughts about what sustainability looks like. This is just my last slide, thinking about a lot of the things we need to think about technology. And I'm going to say, when it comes to the chemical companies, really a lot of the risk is on them. They spend decades looking at these chemistries before they get released. With the ag technology sector, this is so new and it is so volatile. There's companies, I have a map that I have companies where I have in my talks when I go to my vegetable, growers and I talk about technology, I have to pull slides out because that company has gone bankrupt. It's out of business. And I think we need to be thinking about this sector. I'm afraid that, a lot of these companies are new. So a lot of the risk goes on to the growers, goes on to the adopters. If that company is going to be there, if they're going to have the ability to provide you with the services we need. I'm a little concerned about the venture capital aspect of this sector. Can you serve two masters? Can you build something that the growers want and need? And still, the people who made the investment want their ROI too, right? So, I worry about whether that kind of investment is patient enough for, the agricultural industry. So there's a lot of barriers to, that can impact the adoption of these tools, that can impact how we do. I think technology is one tool we need to think of. The cost is going to, the stuff I've shown is all under $50,000, but it's still a capital investment. You have to figure in the availability of parts and services. We're not the carbon robotics laser weeder that's 1.6 million per unit, but the cost is not insignificant. Everyone says, we're going to bring this new technology on and it's going to labor, because labor is going to be gone. But, our labor requirements are really, I think, going to change, not disappear, because we're still going to need people with diverse skill sets. Because I think as this new technology comes on, you're going to have to program, you're going to have mechanical skills, you're going to have electrical training. So what is the workforce going to look like? And frankly, are we training them properly for, a technology, environment? There's a lot of regulatory considerations with these tools. The technology is moving a lot faster than regulatory agencies are. Surprise, surprise. But for instance, right now, our herbicide labels are not written for spray technology. Spray technology changes a lot of things, but that's not in our labels. And if all the spray technology looks different, are you going to have different lines in each label for each type of spray system? I'm going to tell you, a verdant robotic sharpshooter looks different from an eco-robotic system. It's all different. So we need to catch up with that. But we're also going to have capital investment in our systems. A lot of this is going to need cellular service. It's going to need Wi-Fi. And we need to make sure that our government agencies are investing in that. If you see technology as important and they see technology as important, well, then we need investment to support the technology. Again, we got to be thinking about the benefits, and also none of these technologies are 100% standalone. A weed is always gonna win. Okay, we have not gotten rid of them yet. I don't anticipate to get rid of them in the future. We can keep the battle going. I just say the battle has to shift a little bit with the way we've been going after it. So really, we still have to be diversified. We still have to have integrated weed management. And we have to understand if this technology fits into the integrated weed management strategies we want to apply. If you want to use cover crops, does this technology fit or not? It's going to be complicated. And frankly, there's sometimes just not enough time and money to address all the questions. I've got to thank my funding and support. There's a lot of people, in New York State, at the USDA have said, yeah, you know what, we need more data about this. We need data that just doesn't come from the companies themselves. We need independent testing of these tools. And I know nobody wants to take surveys, but I have a survey. And you can just pull up your camera and it'll open up like a little browser and you can wait till later. And I would really appreciate if you would. It is whether you're interested in new technology. If you are, what kind of technology are you interested in? And then what is a driver for adoption and what's a barrier for adoption? And I just want to let you know, right now we have 130 responses and like 50 of them come from New York State, and there's only like 3 from Washington. So I'm going to suggest, for your pride, you should really take this survey, but it also helps us because we can't help you if we don't have the information. And the information could be like, don't invite her back again because this was a waste of our time. All right. I mean, that's fair. Like, this doesn't work for us, like we don't like what you're selling. And that is a fair answer, but we need to know if we want to move forward. And thank you very much. I wanted to make sure that we've tried to get us back on time. Any questions? Yes.
I'm curious if you've seen any disruption with things in the vineyard, rabbits, wolves, ground squirrels.
Yeah, so have we, with the electrical weeder, I
Yeah.
imagine? Yeah, so the first thing, and this was my big mistake, is that Cornell came out to look at it, like the Cornell Cal's leadership, and they said, well, like, what about turtles? And I said, well, if it gets under that, it's gone. And you don't say that. And we have not had any impacts on any mammals and or amphibians and trust me, we have looked. We have looked, we have not had that. I have fried a bunch of insects that were on the plants though, themselves. And I will admit that we have not made are those beneficials or, what species, but, I do know I did cook some aphids that were on like a milkweed or something, but so that is a consideration. We have not had any impacts with any kind of negative impacts on any kind of mammals or reptiles or amphibians, but do not joke with environmental health and safety with
Yeah,
them.
because I can imagine that it's non-discriminatory in the sense of like, if you have a Scottish thistle that the machine's gonna take out and there are pollinators out that are feeding on.
Yeah.
Have you seen deaths of bees or?
We haven't seen, like I said, any death of bees. We know, like, we've cooked some aphids that were on, we have not made like a real close survey of the invertebrates that are in the system. Mostly because I am not good at invertebrate identification, and we just, like I said, we've kind of focused more on our soil microarthropods. My graduate student is looking at that community primarily because we're working with a soil scientist. But we have talked with, Greg Loeb, Monique Rivera, about, well, maybe like the next step is to have, go out with sweeps and see what insects are out there, but again, it's also going to be, mobile. The tractor coming through, can make a lot of things disperse. But it's something that we have to think about, but it's something that we've not, just because, again, there's so many questions we can ask and we are just not there yet with this. And I need an entomologist to come on board. You got one more. I would like a couple more. Oh, yes.
Have you looked at any like speed optimizations for the ATV of the Lead It? Meaning like, so you did 5 miles per hour. Was that recommended by the manufacturer?
We have looked at things. And so what that has, like, pulse width modulation so that it actually adjusts based on your speed.
Have you looked at how fast you can go?
I'm not going, I mostly did not want to go faster than that because Cornell said, don't.
Okay.
Oh, yeah, so it was about the weed it and speed. We had gone 5 miles an hour. The system has modulates based on the speed that you are traveling, so it's adjusting to make the application. And my 5 mile an hour, it was a comfortable pace for my technician, and Cornell has strict requirements on how fast we're allowed to travel on equipment.
With the Zaxo, the speed of that unit seemed to be going fairly slow. But can you increase the speed of that unit if the weed density isn't super high, like in the one picture you showed us where it was literally like.
Yeah.
Out?
So we were going slow because the weeds are so high. So there is an interaction between your generator setting and the speed that you're traveling. That gives you basically the dose of electricity that you've got. Marcelo Moretti in Oregon is actually doing all of those trials. He is actually saying, well, if we go faster with a lower dose and then we come back in a week and do it again, because there's fatigue, right, of driving slow. Part of us is that was our first year with the unit, and there's a lot of, and it was two-sided. And so you have to be looking back and forth, side to side. We have since taken one side off and we're only focused on one side. So we can go a little bit faster because you're just, you don't have to keep moving the hydraulics to manage both sides. But Marcelo is actually doing that, answering that question. We did some work ourselves if we could go faster and with and maybe do twice over. And Marcelo is actually finding, he thinks a faster speed with a lower setting is just as good. So there's that work. It's being done.
Perfect.
Thank you. I'll be here.